What makes a fighter jet the undisputed king of the skies? Is it raw speed, letting it tear through the sound barrier like paper? Is it the sheer firepower it can unleash, a metal storm capable of turning the tide of a battle in seconds? Or is it something more, something you can't see? In the 21st century, the deadliest battles are fought with stealth, advanced sensors, and cutting-edge avionics, long before the enemy even knows what hit them. Forget what you think you know about dogfighting. Today, we're diving deep into the world's most advanced flying war machines. From legendary icons reborn with next-gen tech, to mysterious stealth fighters that are rewriting the rules of air combat. This is the ultimate countdown of the most advanced aircraft flying today. Our first contender is a true beast from the East, the Sukhoi Su-35, known by NATO as the Flanker E. This jet isn't just an aircraft. It's the apex predator of a legendary bloodline, the latest and most lethal iteration of the renowned Su-27 Flanker series. The Flanker story begins in the late 1970s, when the Soviet Air Force launched an ambitious program with a single, clear objective: to challenge and defeat America's formidable F-15 Eagle. Originally a pure air superiority fighter, the Su-27's design proved so successful that its versatility expanded dramatically over the years, incorporating ground attack capabilities and even spawning a naval carrier-based variant, the Su-33. The Su-35 is the culmination of this journey. Marketed as a genuine 4.5 or 4++ generation multi-role fighter, it builds upon the proven strengths of the Su-27 line. It retains its lethal air-to-air superiority while seamlessly integrating advanced ground attack capabilities. Its evolution traces back to the Su-27M development series. The final Su-35 designation was officially introduced in 1993, though the aircraft had already made a public appearance at the 1992 Farnborough Air Show. 10 prototypes were built, some of which were conversions of existing Su-27s, and they entered the Russian evaluation phase in 1996. But what truly sets the Su-35 apart from its illustrious predecessor? The answer lies in a suite of critical innovations. Modernized avionics, extended range, more streamlined aerodynamics, and, most importantly, its new NPO Saturn 117S engines with thrust vectoring control. The official first flight took place in June 1998, and after a lengthy and rigorous testing phase, it finally entered production in 2010, under the designation Su-35S for the Russian Air Force. Its real trump card is its almost supernatural maneuverability. Russian tactics, unlike the Western focus on speed and stealth, have always prioritized agility in modern dogfighting. The Su-35 is the undisputed master of this philosophy. Its thrust vectoring nozzles allow it to perform physics-defying maneuvers that would tear other fighters apart, making tighter turns to evade incoming missiles or to get on an opponent's tail in a close-range dogfight. Under the hood, those two Saturn 117S afterburning turbofan engines are monstrous, each generating 32,000 pounds of thrust at full afterburner. This power propels the Su-35 to a top speed of Mach 2.25 at altitude, or about 1,500 miles per hour, with a service ceiling of 60,000 feet and a blistering climb rate of 55,100 feet per minute. Its operational range is an impressive 1,900 nautical miles on internal fuel alone, which is enhanced by an integrated in-flight refueling probe and an additional internal fuel tank. But power is nothing without an advanced brain. The Su-35 is equipped with the powerful N035 Urbis-E passive electronically scanned array radar as its primary forward-looking system. It complements this with an auxiliary rear-facing radar housed in the characteristic tail stinger, providing the pilot with critical warning of threats approaching from behind. The cockpit has been completely modernized, with a color CRT display, a heads-up display, HUD, and digital fly-by-wire controls with quadruple redundancy, meaning the onboard computers calculate 4 different ways to execute a flight action, ensuring maximum reliability. As a weapons platform, the Su-35S is a flying arsenal. It boasts no fewer than 14 external weapon hardpoints, 12 located under the wings and fuselage. For close quarters combat, it has an internal 30mm GSH-30 cannon with 150 rounds. Its wingtips are typically equipped with R-73 AA-11 Archer short-range air-to-air missiles, though these can be swapped for specialized electronic countermeasure ECM pods. The remaining hardpoints can carry a vast array of Russian-made munitions: air-to-air missiles, air-to-ground missiles, anti-radiation missiles, anti-ship missiles, laser-guided bombs, and rockets, giving it exceptional combat versatility. While the text states that Russia is the sole operator, this is now outdated. In addition to Russia, the People's Liberation Army Air Force of China operates a fleet of 24 Su-35s. Furthermore, Iran has finalized a deal to acquire the fighter, solidifying its role as a key Russian export. The Su-35 has been positioned as a cost-effective, low-risk alternative to the more expensive and delayed F-35, attracting nations looking for top-tier capability without the staggering price tag of 5th-generation fighters. In terms of sheer speed and agility, it surpasses all other existing 4th-generation designs. It remains a lethal and highly respected threat in any combat scenario. Now for a true icon of naval aviation, the backbone of US carrier strike groups for decades. The Boeing F-18 Super Hornet. If there's one aircraft that embodies reliability and versatility, this is it. But its story isn't one of a brand new design, but rather a profound and intelligent evolution. It all starts in the 1970s with the F-18 Hornet, built by McDonnell Douglas and Northrop. It was a pioneering aircraft, the first tactical airframe designed from the ground up to excel in both air-to-air and air-to-ground missions. It was also the first fighter to feature digital fly-by-wire flight controls and carbon fiber wings. The US Navy developed it to complement the more expensive and specialized Grumman F-14 Tomcat, which served as the fleet's primary air superiority fighter and interceptor. However, by the late 1980s, the Department of Defense recognized that the F-14's technology was becoming outdated, and its production was cancelled in 1991 in favor of producing more Hornets. This led to a major redesign. In 1992, the US Navy placed its first order for this new, upgraded version, dubbed the Super Hornet. It made its first flight in November 1995 and was officially approved for service in February 2000 after extensive testing. The Super Hornet is about 25% larger than its predecessor, with a wingspan of nearly 45 feet and a maximum takeoff weight of around 30 tons. It's powered by 2 General Electric F414-400 turbofan engines, which push it to a top speed of Mach 1.6, or nearly 1,200 miles per hour at 40,000 feet. But its real value lies in its multi-role capability. During the Vietnam War, the Navy required up to 6 different types of aircraft to perform the duties now handled by a single Super Hornet, saving hundreds of millions of dollars annually. As a weapons platform, it is formidable. It's equipped with a 412-round M61A2 Vulcan gun and has 11 hardpoints with a maximum payload capacity of over 8 tons. It can carry a wide range of missiles, air-to-air, air-to-ground, and anti-ship, as well as a variety of bombs, mines, and targeting pods like the AN/AAQ-28V Lightning. Its upgraded avionics, like the Raytheon APG-79 AESA radar, give it a significant edge in combat. The Super Hornet continues to evolve. The latest upgrade, known as Block 3, is a game-changer. This new version features an advanced cockpit with large touchscreen displays, a new adjunct processor to handle more tasks faster, and a reduced radar cross-section to enhance its stealth capabilities. Critically, its service life has been extended by 4,000 flight hours, bringing the total to an incredible 10,000 flight hours. While the source material mentioned production ending in 2025, Boeing has since extended the production line to 2027 to accommodate potential new international orders. This ensures that this dependable workhorse, currently in service with the US Navy and multiple allies, will remain the cornerstone of naval aviation strike warfare well into the 21st century. Some legends never die. They just get a massive upgrade. Meet the F-15EX Eagle II. The original F-15 Eagle was born from the hard-learned lessons of the Vietnam War. Early versions of the F-4 Phantom II, while powerful, struggled in close-range dogfights against more agile MiGs. They were designed for long-range missile combat and initially lacked a cannon. This experience led to a major reassessment. The US Air Force demanded a pure, uncompromised air superiority fighter that could dominate the sky. The result was the McDonnell Douglas F-15 Eagle, an aircraft that for decades was simply untouchable, boasting a combat record of over 100 kills with 0 losses in air-to-air combat. However, by the 2000s, the US Air Force's F-15C/D fleet was aging. The original plan to replace them with 381 F-22 Raptors was cut down to just 187 aircraft, leaving a significant capability gap. Restarting the F-22 production line was deemed too expensive. Meanwhile, Boeing had been developing advanced versions of the F-15E Strike Eagle for export customers, like the F-15SA for Saudi Arabia and the F-15QA for Qatar. These new models featured major upgrades, including a redesigned structure, fly-by-wire controls, and advanced cockpits. Seeing an opportunity, the US Air Force and Boeing collaborated on a new variant based on the F-15QA, dubbed the F-15X. The Air Force selected the two-seat EX model and, in July 2020, placed an order for the first batch for $1.2 billion. The F-15EX Eagle II officially took its maiden flight in February 2021. While it's not a stealth fighter like the F-22 or F-35, it's designed to be their perfect partner, excelling in roles like homeland defense and, most importantly, as a flying weapons arsenal. Think of it as a missile truck. Thanks to its new Advanced Missile and Bomb Ejector Rack (AMBER) system, the F-15EX can carry an unprecedented payload of up to 22 air-to-air missiles. The strategy is clear. Let the stealthy F-22s and F-35s sneak into contested airspace, identify the targets, and then have the F-15EX launch a massive volley of missiles from a safe standoff distance. It can also carry large standoff munitions, like the AGM-158 JASSM cruise missile, or even the AGM-183 ARRW hypersonic weapon. It also boasts a brand new digital fly-by-wire control system, which improves maneuverability and allowed for the activation of 2 extra wing pylons that were disabled on older models due to stability issues. Its redesigned airframe has a service life of a staggering 20,000 hours, a massive improvement over the 8,000 hours of earlier models. The cockpit is completely modernized with large aviation displays and an advanced display core processor. It's equipped with state-of-the-art systems like the Raytheon APG-82V1 AESA radar, an infrared search and track IRST pod, and the Eagle Passive/Active Warning and Survivability System, EPAWSS, a cutting-edge electronic warfare suite. The Air Force's current official plan is to acquire a robust fleet of 104 Eagle IIs. The F-15EX is a powerful statement that a legendary, combat-proven design, when infused with the latest technology, can become an indispensable asset in 21st century air warfare. world of fighter jets, France has always marched to the beat of its own drum. And the ultimate expression of that is the gorgeous and deadly Dassault Rafale. The name means burst of fire, and it's a fitting title for this incredibly versatile machine. Its story begins in the late 1970s, when France, along with other European nations like West Germany and the UK, tried to develop a collaborative fighter. However, disagreements quickly emerged. A new initiative, the Future European Fighter Aircraft Program, was launched in 1983, bringing together Spain, Britain, Italy, France, and West Germany. But again, friction arose. France wanted a lighter, multi-role aircraft that could serve both its Air Force and its Navy, with strong export potential. Britain, on the other hand, needed a long-range air defense interceptor. France also insisted on leading the project, which didn't sit well with the other partners. In 1985, France officially withdrew to pursue its own path, determined to maintain its technological independence in aerospace. The remaining nations would go on to develop the Eurofighter Typhoon. Dassault was tasked with creating a fighter that could do it all, replacing up to 6 different types of aging jets in the French inventory. The result was the Rafale, an aircraft designed for omnirole capability, the ability to switch between air superiority, deep strike, and reconnaissance missions in a single sortie. It made its first flight on July 4, 1986, and production was ordered in 1988. Its distinctive delta wing and close-coupled canard design gives it phenomenal maneuverability and excellent flight characteristics, especially at high angles of attack. The aircraft is deliberately designed to be aerodynamically unstable to enhance its agility, relying on a sophisticated fly-by-wire system to remain controllable. For carrier operations, this design allows for a remarkably low landing speed, increasing safety. Powered by 2 Snecma M88 turbofan engines, the Rafale can supercruise at Mach 1.4 and reach a top speed of Mach 1.8. But its real strength lies in its advanced avionics and sensor fusion. The Rafale features the RBE-2 AESA radar and a unique front sector optoelectronic system called OSF, which allows for long-range, passive target identification. Its most prized asset, however, is its Spectra electronic warfare suite. This highly integrated system provides long-range detection, identification, and localization of threats, allowing the pilot to take immediate defensive action through jamming, decoy deployment, and evasive maneuvers. While the source material mentions a specific unconfirmed report about a simulated engagement between an Egyptian Rafale and an Su-35, it's crucial to note this has never been officially verified. Nonetheless, the Spectra system is widely regarded as one of the most effective in the world. The Rafale is armed with a 30mm autocannon and has 14 hardpoints, 13 on the naval model, capable of carrying over 9,500 kilograms of ordnance. This includes Mica and Meteor air-to-air missiles, Scalp cruise missiles, and even the ASMP-A nuclear missile, making it a key part of France's nuclear deterrent. It has been upgraded through multiple standards, with the latest F4 standard introducing advanced network connectivity and new weaponry. The Rafale has been a major export success, with operators including Egypt, Qatar, India, Greece, Croatia, the UAE, and Indonesia, with Serbia also finalizing a deal. It has seen extensive combat, from Afghanistan and Libya to operations against jihadists in Mali and ISIS in Syria and Iraq, proving itself as a supremely capable and reliable omnirole fighter. What do you get when you combine the looks of an F-22 with the battle-tested systems of an F-A-18? You get South Korea's ambitious new fighter, the KF-21 Boramae, or Fighting Hawk. Living under the constant threat from North Korea, South Korea has, for decades, invested heavily in building its own advanced domestic defense industry. The KF-21 is the crown jewel of this national strategy. The project officially began in 2001, born from the need to replace the Republic of Korea Air Force's ROKAF aging fleet of F-4 Phantoms and F-5 Tigers. While buying fighters from abroad would have been cheaper, the government prioritized establishing a domestic military aviation industry. After years of funding challenges and delays, the project gained significant momentum in 2010 when Indonesia joined as a partner. While that partnership has faced significant payment issues and has since been renegotiated, it remains in place. Now, while it looks like a fifth-generation stealth fighter, it was intentionally designed as a 4.5-generation jet, a bridge between the two. The initial requirement was for a stealth capability greater than existing fourth-generation fighters, but less than the F-35. The first production versions, known as Block 1, will have limited stealth features and carry weapons on 10 external hardpoints, 6 under the wings and 4 semi-recessed under the fuselage. Future versions, like Block 2, will introduce surface attack capabilities, and later blocks are planned to incorporate internal weapons bays for a true stealth configuration. This phased approach makes the KF-21 much more affordable to build and maintain than a full fifth-gen fighter from the outset. It's powered by twin General Electric F414 GE400K afterburning turbofans. The same reliable and powerful engines used in the Super Hornet and the latest Gripen fighters. These engines give it a top speed of Mach 1.8 and an unrefueled range of 2,900 kilometers. The first prototype was unveiled in April 2021, and it made its maiden flight in July 2022, followed by its first supersonic flight in January 2023. The strategy for its use is brilliant. The ROKAF also operates the fully stealth F-35A. The plan is to use the F-35s as stealthy scouts to sneak in and find the enemy, then use the KF-21 with its larger ordnance capacity to deliver the firepower, all while linked together in a deadly network. A potential two-seat version could even be used to control accompanying combat drones, acting as a command center in the sky. The Boramae is a smart, cost-effective approach to modern air combat, and a clear sign that South Korea is now a major player in the global aerospace industry. The Eurofighter Typhoon is what happens when some of Europe's biggest aerospace powers, the United Kingdom, Germany, Italy, and Spain, team up to build a world-class air superiority fighter. The journey, however, was long and fraught with challenges, a perfect example of the complexities of multinational joint ventures. The story begins in 1979 with a program initiated by British Aerospace and West Germany's MBB, later joined by France's Dassault. But disagreements over design philosophy and engine choice led to the collapse of the partnership. In 1983, a new consortium was formed between the UK, France, Germany, Italy, and Spain to develop the Future European Fighter Aircraft, FIFA. But once again, differing requirements. France wanted a carrier-capable element and demanded leadership of the program, caused a split. France went its own way to create the Rafale, while the UK, Germany, and Italy, later rejoined by Spain, forged ahead with their own European Fighter Aircraft, EFA project. The result is an absolute monster of a jet designed for one thing: performance. The Typhoon is a purebred dogfighter built for speed, power, and agility. Its combination of a delta wing and canard foreplanes makes it incredibly nimble and highly unstable, relying on a sophisticated computer-controlled fly-by-wire system for control. Its two massive Eurojet EJ200 engines deliver a phenomenal thrust-to-weight ratio, allowing it to climb like a rocket at over 62,000 feet per minute and reach a top speed of around Mach 2. It can even supercruise, flying at supersonic speeds without using its fuel-guzzling afterburners, a key tactical advantage. Its glass cockpit is a high-tech marvel, featuring 3 large multifunction displays, a wide-angle HUD, and even direct voice input for voice command support, all designed to minimize pilot workload. Its advanced Euro radar captor is a multi-mode pulse Doppler radar that provides excellent look-down/look-up capability and resistance to jamming. The Typhoon's defenses are managed by the Praetorian Defensive Aids subsystem, a sophisticated suite that includes radar and laser warning receivers, missile approach warners, chaff and flare dispensers, and even towed decoys. Originally a pure air-to-air interceptor, the Typhoon has been progressively upgraded through different production tranches. While the source material mentions the future integration of the Meteor missile, this is outdated. The long-range MBDA Meteor is fully operational and is one of its most lethal weapons. The program has now moved on to Tranche 4, and major upgrades are underway, including the revolutionary ECRS Mark II AESA radar, which will provide sophisticated electronic attack capabilities. It's armed with a 27mm Mauser cannon and 13 external hardpoints. For ground attack, it can deploy a wide variety of ordnance, including paveway laser-guided bombs, the Storm Shadow cruise missile, and the Brimstone anti-armor missile. The Typhoon is a powerful testament to what European collaboration, despite its challenges, can ultimately achieve. And now, Russia's answer to the F-22, the enigmatic and highly controversial Su-57, codenamed Felon by NATO. This is Russia's first ever stealth fighter, a project that began in 2001 under the name PAKFA, rising from the ashes of cancelled Soviet-era programs to develop a fifth-generation fighter. The goal was ambitious: to create a jet that would replace the aging MiG-29 and Su-27 fleets and surpass the legendary flankers' capabilities. After a competition between MiG and Sukhoi's more advanced, albeit more expensive, T-50 concept was chosen. The prototype was built by 2009 and made its first flight in 2010. The project, however, has been plagued by funding challenges, economic sanctions, and delays, with the first production model entering service only in late 2020. The Su-57 is a fascinating blend of stealth shaping and the raw maneuverability that Sukhoi is famous for. While its all-aspect stealth is widely debated and considered by many Western analysts to be less effective than that of the F-22 or J-20, it has some unique tricks up its sleeve. The aircraft features an innovative system of multiple AESA radars, including side-facing arrays mounted on its cheeks. This gives its pilot unparalleled 360 degrees situational awareness and the ability to track a target even when flying at a 90-degree angle to it, a huge advantage in missile combat tactics like notching and cranking. It also boasts a sophisticated electro-optical suite, which includes an infrared search and track system and a directional infrared countermeasures DIRCM system that uses lasers to blind the seekers of incoming heat-seeking missiles. It carries its weapons, including up to 6 R-77M air-to-air missiles, in internal bays to maintain its stealth profile. Powered by its initial AL-41F1 engines, the Su-57 can supercruise at Mach 1.3 and reach a top speed of Mach 2.0. The long-awaited, more powerful Izdalia 30 engine, which will enhance performance, has not yet been integrated into production aircraft. Russia claims it has used the Su-57 in combat over Ukraine since 2022, primarily firing long-range R-37M missiles from within the safety of Russian airspace to avoid heavy air defenses. However, it's critical to note that there is no independent visual evidence of these missions. In June 2024, satellite imagery confirmed a Ukrainian drone attack successfully damaged at least one Su-57 on the ground at Akhtubinsk Air Base, a significant blow to the prized fleet. Production remains extremely slow, with current estimates suggesting only about 25 to 30 serial aircraft have been delivered to the Russian Air Force, making the goal of 78 by 2028 highly unrealistic. The Su-57 Felon remains a highly prized, controversial, and rare asset. Its true potential still constrained by production and engine development challenges. Finally, we come to the aircraft that represents a monumental shift in global air power. China's Chengdu J-20, Mighty Dragon. For decades, the West held a monopoly on stealth technology. The J-20 shattered that forever. Shrouded in secrecy, the J-20 is a large, heavyweight stealth fighter designed for one primary mission: air superiority, with the goal of competing on equal footing with the US F-22. Its development was driven by a 2003 strategic paper outlining the need for a heavyweight fifth-generation fighter. Its long fuselage, canard delta layout, and sophisticated edge alignment are all optimized for low observability, challenging early Western skepticism that canards were incompatible with stealth. The designer claimed this configuration generates 1.8 times more lift than a pure delta wing, granting it excellent performance. The J-20's avionics are top tier. It features a large AESA radar, 6 electro-optic aperture sensors, providing 360-degree coverage, similar to the F-35 system, and a glass cockpit with a large LCD touchscreen and a holographic heads-up display. It carries its weapons internally to maintain stealth. The main weapon bay can carry 4 PL-15 beyond visual range missiles, a formidable weapon with an estimated range of over 200 kilometers that outranges many Western counterparts. 2 smaller lateral bays house the PL-10 short-range, high-off boresight missile for dogfighting. One of the biggest challenges for the J-20 has been engine development. Early models used Russian Saturn engines, followed by improved Chinese WS-10C engines. But now the game has changed. The latest production variants are being equipped with the long-awaited domestically produced WS-15 engine, which finally provides the J-20 with true fifth-generation capabilities, including supercruise and superior thrust. What's truly staggering is the speed of its production. Recent estimates from the Pentagon and other intelligence sources suggest that China now has a fleet of over 250 J-20s, with a production rate that may exceed 100 aircraft per year. This makes it the most rapidly produced stealth fighter in the world. Furthermore, China has developed a 2-seat variant, the J-20S, the world's first 2-seat stealth fighter. This variant is likely designed to act as a command and control platform, coordinating swarms of loyal wingman drones like the GJ-11 Sharpsword, a concept central to China's vision of future networked warfare. The J-20 Mighty Dragon isn't just a jet, it's a statement. It's a symbol of China's technological rise, and a clear sign that the skies of the 21st century have become a far more competitive arena.
For any Iranian pilot to get into the F-14 program, he had to have 1,000 hours in either the F-4 or the F-5 to even get in the program. But it was obvious that they were never going to have a squadron as good as our squadron in tactics and understanding, etc. They were going to be good enough to fly those things and fight them against the Iraqis and other people. That would be fun. But not against the United States.
412, receive my navigation now from position direct. It's on a Dempsey 154 with the climbing throttle 290 and a heading 145. Dempsey 154.6, confirm your requesting season level please. 330,
after the end of '72, I had a set of orders to go to test pilot school. I went to Pax River because in 1967, 68, I was working at a company called Sunstrand, and I was the senior applications engineer on the design of the wing sweep system for the F-14. And I happened to be giving a presentation to Grumman the day they announced on their PA system that they'd won the competition to build the F-14. So I went to Bob Smythe, who was the chief test pilot at Grumman, and I said, hey, I got to fly this airplane. And he said, well, he said, you're in the reserves. He said, you haven't been through test pilot school. He said, I recommend you go back on active duty, go to test pilot school. It's a 6-month course. They require you as a 1-year payback, 2-for-1 payback. So you got to be in flight test for a year. And he said, I don't need anybody right now anyway. And he says, by that time, I'll be looking to hire some more test pilots, and I'll hire you because of your engineering background and the fact you worked on this airplane for the last 2 years for us. I'll hire you. So that's how I ended up back at Miramar. Bob Rasmussen said, he's not going to go to test pilot school in F-4s, he's going to go to the RAG. But now I'm on my way to test pilot school finally. I get there, and the Navy's already got the F-14 at Pax River testing them. I graduate from test pilot school, and because I'm now a senior lieutenant commander, they said, hey, we'd like you to go be the head guy on fighter flight test out at Point Mugu, and you'll be in charge of doing all the F-14 weapon systems test fly, which is where I went. And I'd been there about 2 years, and we're doing the V&V, as we call it, validation and verification of the new tactical software that was going into our fleet F-14s. And that was the first production tape, as we call it, that we loaded into the weapon system. At the same time, the Shah of Iran bought, through however he got around to doing that, bought the F-14, bought 80 F-14s. And so one of the tasks that we were given, myself and my people, were to develop a tape for their weapon system. It was kind of detuned. It didn't have all the electronic countermeasures and countermeasure stuff in it that we had in ours. At that time, they were good allies of ours. You know, the Iranians were good allies. We had, you know, the United States government had put the Shah back in as the king, or the Shah. And so, you know, with Iraq being Iraq and the Russians being the Russians, you know, they had F-4s and they had F-5s. They had, you know, 1,000 F-4s and probably that many F-5s, and our tanks and surface-to-air missiles and everything else. I mean, they were one of our strongest allies. And so it didn't really bother me that they had them. I never once thought we'd ever be fighting them, you know, F-14 to F-14. We flew over to brief the Iranian Air Force guys and the Grumman and Hughes people that were going to be loading it and maintaining it in the test equipment and the aircraft. We went over to brief them, and somebody said, oh, wow, as long as you're going over there, why don't you take 2 of their deliverable airplanes with you? So we flew an 8-hour flight from Bethpage to Rota, Spain, and then we flew another 8-hour flight from Rota, Spain to Isfahan, Iran, into Hatami Air Base. We were the first 2, that was ship 3 and 4. 3rd and 4th airplane that was delivered to the Iranian Air Force into Hatami Air Base. And we were the first ones to show up at Hatami. It was a brand new base built out in the middle of nowhere out in the desert. And we're taxiing into the front of operations, and they stopped us in the throat of the taxiway. And they got a band and a bunch of troops and a bunch of civilians over there, and they bring this goat out, and they sacrifice this goat right in front of us on the taxiway. And John, who's this grizzly old Marine that's got like 10,000 hours, of 8 of which is in Korea during the war, he goes, "Oh my God, I can't believe I just saw that." And I'm going, hey, you know, it's their Air Force. It's that way they bless this whole thing. We are all right. We are the good guys. And so I was there, and I had to go. We briefed them, and then they invited us up to Tehran to brief all the powers to be in the Military Advisory Assistance Group, the MAG as they call it. And there was an Air Force general by the name of Dick Secord. You probably heard that name, Iran-Contra. He was the new guy up there, and he said, "Hey, get up here and tell me all about this thing. You need to tell me all about the F-14." And the F-14 fell under him as the Air Force advisor because it was in the Iranian Air Force. And the Navy advisor had nothing to do with the F-14 program. So I briefed him. I went home. And about a year later, maybe not even a year, I get a call from the Chief of Naval Operations and says, "Pack your bags. You're going to be the new commander of the F-14 program in Iran. You've been requested by the Air Force General." And I went, what did I do to tick him off, you know? It turns out that Whitey Feitner was part of that whole thing, that they had to have a senior officer over there with a background in the F-14 that really knew what was going on, and who was, you know, a grizzled old flight instructor as well. For any Iranian pilot to get into the F-14 program, he had to have 1,000 hours in either the F-4 or the F-5 to even get in the program. And, you know, you got to remember that they speak Farsi, and everything that we taught them was in English at the direction of the Shah, because the Shah wanted everybody to be very fluent and understanding of the English language, because he wanted their Persia, as they called it, to take their place again in the important communes of the world, because at one time they ruled the world. And so his whole goal was to, you know, bring Iran back to the table with the United States, Germany, Russia, and everybody else, be equals. But it was obvious that you know, they were never going to have a squadron as good as our squadron in tactics and understanding, etc. They were going to be good enough to fly those things and fight them against the Iraqis and other people. You know, that would be fun, but not against the United States. I went over there in February of '77, leaving Point Mugu in the F-14 program. And I stayed there as the commander of the team, the group there at Hatami Air Base until April of '78. And I was brought back to the Naval Air Systems Command in Washington, D.C. to be the director of foreign military sales by Admiral John Albus. In September of '78, I was part of a program review in Iran. So the admiral, my boss, and 2 or 3 other admirals and a bunch of people went over there for a program review. The end of August, first part of September, there was what we call progress payments. Every month, the government of Iran would write a big check for millions of dollars on their contract to buy the test equipment and the aircraft and pay for the manpower and everything else that was over there supporting this program. And they missed the payment. And so technically that's a default on a contract between the governments. And so we went over there with that in our back pocket, and we come to find out there's a bunch of problems going on over there relative to unrest in the troops. It was kind of like they were drafted for 7 years, and then when they were supposed to get out, they weren't letting them out. And that generated a lot of hate and discontent. And it looked like things were not good. So we came back to the States. That was the last time I was in Iran. We had some 500 civilian contractors for Grumman, Hughes Aircraft, Pratt & Whitney, Nawasi, North American Worldwide Services, down in Isfahan. Funny thing, I was with the Admiral, and we were having our program office Christmas party down in Alexandria for lunch, and I got a call from this guy that was part of the Defense Intelligence Agency guy in the embassy in Tehran, and I was briefing with him a lot when I was over there. And he calls me up and he said, hey, Hot Dog, I need to have you come talk to us about Iran. And I'm going, okay, when next week or no? He says, no, right now. I have a car that's going to pick you up in 15 minutes, be there. So I go up to the Pentagon, and I find out that things are really coming unraveled, and they want me to evacuate all of our people from Isfahan. And so we started the process right then and there in evacuating the 500 people that we had down in Isfahan. We had something like 40 or 50 just involved with the F-14 program, and probably not that many, probably 30 people in Tehran that were part of that F-14 program. But we started that evacuation issue right then. Then, as everybody knows, the Shah left the country in the first part of '79. Khomeini came in, they had a revolution, and they stormed the embassy, I think it was in October of '79. I had 2 F-14 guys in the embassy when it was stormed. Commander Don Scher, and unfortunately I can't remember the other guy's name, but he was from the technical support side from Philadelphia, that were there in the embassy for the whole duration. I had fought to keep them in the United States when they were back in, they were in my office, I think, in June, and I told them to go home because they're not going back. I'd already gone through the evacuation. There's no sense in sending 2 guys back over there again. And about a week later, I got a phone call from a 4-star Air Force general at Sinkyur asking me who the heck I thought I was. They worked for him and his people, not for me. And we had a little argument about that. And he said, well, you got 24 hours to send them, or I'm calling up your boss and let you deal with him. And that boss he was talking about was the Chief of Naval Operations. And I thought, boy, I don't want to put my boss in trouble. So I went and talked to him, and he said, geez, send them. We don't need a battle with the boss. And so reluctantly, I sent him back over there on the Air Force MAG's call, and they ended up being POWs. Not good.
White was the commander of the Flight Test Center. He asked me if I wanted to take over the F-15 program. And so naturally I agreed quickly. And as I said earlier, before we started this, I had been at Edwards for 3 years already. And so I spent another 3.5 years doing the F-15 program. So this was in the summer of 1970. And then the first flight was in 72. So I took over 1 year before first flight of the F-15, and I had it for 2 years after that. So I was the first Air Force pilot to fly the F-15. And we did a lot of evaluations as an Air Force of the F-15 early on. The situation with the F-15 was designed strictly for air-to-air, so it had great turning capability. In fact, one test point I had was a 5G accelerating turn. So you're going around and around at 5 Gs. And then it gets to be very difficult. The difference between what the F-15 could do and like when they went operational in 1974 and what the F-4 could do was the fact that the performance was so much greater as far as climb, turning, acceleration, all the performance parameters. Now the analysis people that in the Pentagon can analyze the expected performance of all the Russian airplanes. And they show part of the envelope where the two compare, favorably or unfavorably. And the F-15, compared to all the data we had on the Russian or USSR airplanes, the F-15 was far superior. They have what we call piece of S, which means the excess energy that you have in any given flight condition. And the F-15 was far superior in all categories of performance. Now, the thing that I haven't mentioned yet, the F-15 had such great radar systems. When we were talking about the radar in the Korean War, even the F-101, the radars, the F-15 was such that you just push your little joystick over here, and it would lock onto an airplane. It would give the information of what the other airplane was doing, its number of Gs, airspeed, everything. So it was, the avionics was far superior. The F-14 and F-15 were entered service almost at the same time. They tried to fly it earlier and beat us, but when they lost that airplane, that was a little bit later. So the two were being developed almost at the same time. And of course, there's always the controversy that says which airplane's better. So after I'd flown the airplane, I don't know how many hours I had, it was in the fall of 73, a Navy admiral and an Air Force general decided that we ought to evaluate these two airplanes, not against each other, but have a test pilot evaluate the capability of the other services airplane. So I was going to evaluate the F-14, and a Navy pilot, test pilot, was going to evaluate the F-15. And the ground rules that we had was very specific. We write an analysis of what we think of the airplane that we're evaluating. No comparison between the two. So we did that. And I flew about 15, 16 hours, I guess, in the airplane. I had my own backseater, and we did a full evaluation. So we got to go to the Pentagon and evaluate the results. So George White, who was the Navy guy that flown the F-15, gave his report, and I gave my report on the F-14. And the first question from 4-star in the front row was, how do they compare? The answer had to be diplomatic. And the answer I gave was that the F-14 is designed for long-range missile, the Phoenix missile. The F-15 only has short-range missiles and medium-range missiles, which the F-14 always had. So for that mission, for fleet defense, the F-14 was better for that mission. For what the Air Force mission was, the F-15 was far superior for that mission. And then, as an aside, to be able to go aboard the carrier, you're about 15,000 pounds heavier than the F-15. So the performance is lacking because the thrust of the engines, the F-14 and F-15, were almost identical in afterburner. After we got through briefing all the generals and admirals, then the Armed Services Committees of Congress wanted to get involved. So both George White and myself got to testify before the Senate Armed Services Committee and the House Armed Services Committees. And they wanted to know all the nitty-gritty about how the airplanes compared, and they weren't interested in anything politically. They just wanted to, how did they compare, and so we kind of had to answer their questions. We couldn't take the fifth with them because the admirals and generals didn't want any direct comparison of the F-14 and F-15. But we got to do that to finish up that part of the program. Now the other part of the F-15, as I left, began to leave it in 1974, which is 2 years after first flight. We flew from Loring, Maine to Bentwaters, England, non-stop, unrefueled, which no fighter has ever done that before that. Of course, Lindbergh flew across his little Spirit of St. Louis. But for a fighter, you always had to have tankers or go the northern route where you went across and made all your stops in Newfoundland, Greenland, Iceland, and that sort of thing. But we flew nonstop from Loring, Maine to Bentwaters, England. And that was associated with the Farnborough Air Show in 1974.
Every aircraft has a story that deserves to be told. Don't let these legends fade into the past. Like this video and subscribe to our channel and help us keep aviation history alive.